genetic sequences of growth factors.
Engineering is all about making the world a better place, and scores of research projects at the University of Kansas School of Engineering strive to reach that goal.
We're working on developing new retrofits and new techniques to extend the lives of existing steel bridges.
We're focused here on drug delivery systems and tissue engineering for things like cartilage regeneration.
In the fall of 2012, faculty and students added a valuable tool in those research endeavors, the Measurement, Materials, and Sustainable Environment Center, funded in part by a grant awarded from the National Institute of Standards and Technology. The School of Engineering's newest facility houses multiple cutting-edge research areas under one roof.
I think what separates us here is the fact that you not only have a philosophy of interdisciplinary education, but you have a state-of-the-art building in which to carry it out.
A closer look shows just how revolutionary this building is and highlights how researchers will have new opportunities for greater discovery.
So it helps to prevent the signals actually going in to reach the walls.
One such feature is the anechoic chamber. It's a room covered in foam panels that have the effect of soundproofing the room, but they're actually in place to prevent interference from outside radio signals.
So this chamber allows us to develop better system, more sensitivity, so then we can deliver more accurate data to the scientists to study the polar regions.
This research is a direct benefit to KU's Center for Remote Sensing of Ice Sheets, a leading global center for remote sensing of the polar regions and climate change.
This is the center array from the NASA P-3 aircraft that's been flying for the NASA Operation Icebridge.
Associate Professor of Aerospace Engineering Rick Hale and his team design and construct aircraft and attach ground-penetrating radar designed to provide 3D maps of ice sheets all the way to the bedrock.
We've been growing out of our space to get the types of resolution we need to get deeper through the ice sheets. We need larger arrays. And so this space will allow us to do that in a high-quality, repeatable fashion.
Another unique feature of the building
So this is the strong box loading area.
is a space in the fracture and fatigue lab to test the strength of materials in 3 dimensions. Aerospace engineers can test aircraft wings, and civil engineers can experiment with a variety of forces on bridge components.
This is going to allow us to apply not only loads that we can react against the floor with, but we can react against a ceiling, against walls.
This setup will help KU embrace its position as a national leader in bridge safety.
We're using novel materials to do that. We're coming up with new techniques that are aimed at saving the state and taxpayers money. And generally making our infrastructure safer.
The Measurement, Materials, and Sustainable Environment Center also has labs dedicated to improving health care at an affordable cost. Chemical and Petroleum Engineering Professor Stephen Gerke is the Director of Graduate Studies for the Bioengineering Graduate Program. He shares lab space with Professor of Chemical and Petroleum Engineering Michael Dedamore. The two conduct similar research on biomaterials in hopes of improving drug delivery and cartilage regeneration. Before this facility opened, the two worked in separate buildings.
Instead of having a bunch of tiny little labs and we're carrying samples back and forth from one building to the next, we're just carrying them across.
In addition to a variety of improved safety features, the lab enhances efforts to strengthen this region as a key player in bioscience research.
We've kind of promoted very entrepreneurial spirit to help develop the economy here in Kansas in the biomedical products area.
The building brings together many of the programs for KU's Transportation Research Institute, including the Feedstock to Tailpipe Initiative, which focuses on producing and testing and certifying alternative fuels. It's expected the building will provide a setting for much more efficient operations.
Where I can make fuel, literally go 2 doors down, test the chemical and physical properties of that fuel across a whole suite of standards, and then walk across the hall and use that fuel to determine what the mechanical and emissions characteristics are.
The entire building is designed with that type of convenience and a focus for creating additional interdisciplinary research connections.
Materials development is clearly one of the foci of this new building, and we see biomaterials research labs surrounding us. And these labs are likely to develop a new material, whereas in our lab is likely to apply that new material, perhaps to a small unmanned aircraft for remote sensing.
The building setup is also expected to encourage additional opportunities for discovery.
People even get a chance to eat together. And when you can share a coffee, you can share a meal, that conversations are bound to happen. And especially people that are working on seemingly disjoint subjects have an opportunity to see, hey, what are you working on? what are you working on? You know, and then they may see overlaps or maybe some serendipity there.
The structure itself is capable of serving as a learning space for another type of environmentally sustainable research.
And then you can replace the panel, put it back up, and clamp it in.
2 exterior walls are lined with 63 interchangeable panels that test and monitor different materials aimed at providing better ways of controlling building heating and cooling.
The energy that's absorbed in the phase change process at night then, for example, after a hot day at night, can then be re-radiated back in the atmosphere, not into the building.
And the roof will have a greenhouse to grow different types of algae for alternative fuel experiments, as well as space for wind energy research. The Measurement, Materials, and Sustainable Environment Center. It combines groundbreaking research in a state-of-the-art building while bringing some of the world's top engineering minds together in one place.
Feeling like you're contributing to problems that need to be addressed in the very, very near future, that's an exciting thing. I mean, engineers like to build stuff, to fix stuff, to address problems that are real, and they get an opportunity to do that here in this space.